Welcome everyone to Math 104 Final Exam Review, Part 3. Working on Chapter 5 today, Factoring. I've got quite a few problems listed in the review. I'm only going to go through a few of each type. I recommend practicing each type as much as you need to. So the first one is a GCF problem. You can see something that looks like a big mess like this. It's probably not factorable other than factoring out a GCF. So we're going to look at each of these three terms, starting with the numbers. I want the largest number that can divide evenly into 12, 8, and 20, and that's 4. Now for each variable, just select the smallest exponent. So for Q, smallest exponent is 1. So we have Q's in all three, we have B's in all three. And for B, the smallest exponent is 1. So GCF is 4QB. So that goes on the outside of the parentheses, and then inside, we're going to put the result of taking each term and dividing by the GCF. 12 divided by 4 gives us 3. Q squared divided by Q is Q, and the B's cancel. So 3Q for the first one. And the second one, 8 divided by 4 is 2. Q divided by Q, those cancel. B squared divided by B is B. So 2B for the middle term. Make sure you're watching the signs. We're going to subtract the last term. 20 divided by 4 is 5. Q to the third divided by Q is Q squared. B squared divided by B is B. And that is all we can do with that one. Now the next one is a 4-term polynomial. So always with 4-term polynomials, we're going to look to factor by grouping. Now this one happens to be in an order that cannot be factored by grouping. Notice in these first two terms, there is no GCF other than 1. So we're just going to rearrange these. So I can get an x next to this x squared. And then I want to arrange them kind of the same pattern. So the second term here is a 5, so the second term here is a 5. Right now we can factor by grouping. I'll factor an x out of the first one. Get x plus 5, factor out a y from the second group, and get x plus 5. And there's our matching binomial. We can then factor that out. X plus 5 times x plus y. Right, number 10, another factoring by grouping. This one is in, it's not quite in the order we want. Pretty close though. Just going to switch to these two. That puts the 3 in the second position here and the 3 in the second position there. Now we can factor by grouping. So we'll factor out, wait a second. Here's a 3x. Copy that down. There we go. Okay, now it makes sense. Factor out an x here and get x plus 3. And here I'm going to factor out a negative y and get x plus 3. There's our matching binomials. Factor those out, x plus 3, x minus y. Now this is actually from page 366. There's a whole bunch of factoring problems there in section 5.4, general factoring strategies. A lot of good practice problems there. So this is one of the more basic kinds. We got an a equals 1 trinomial. And so all we have to do is look at this number here, find two numbers that multiply to get negative 16, that add to get negative 6. So we're going to factor this into things like 16 and 1, negative 8 and 2, and there's 2 that add to get negative 6. So there's our two numbers. A minus 8. 8 plus 2. And as always, make sure you have 4 of these checked. It's a great way to catch those little mistakes that come up. Now, in the next one, we have an a not equal to 1 trinomial. So we're going to use the AC method for this one. So we'll take a, the value of a is 6. And c is negative 10. And we're going to multiply together a times c. And get negative 60. All right, now we need two numbers to multiply to get negative 60, add to get 11. And those two numbers will be negative 15 and 4. Wait, wrong side. 15 and negative 4. All right, so those two multiply to get negative 60, add to get 11. So these two numbers we will use to split up that middle term into 15k minus 4k. And now we have a 4-term trinomial we can factor by grouping. So out of this one, greatest common factor of 6k squared and 15k is 3k. Factor out 3k, get 2k plus 5, and over here we can factor out a negative 2 and get 2k plus 5. There's our matching trinomial, so 2k plus 5 times 3k minus 2. Now for 18, we have, notice we have b's in all three terms. So that's a clear sign we need to factor out a GCF first. We also have a common factor of 3 between 6, 9, and 15. So I'm going to factor out a 3b. And inside the parentheses, we get 2b squared minus 3b minus 5. So here is an a not equal to 1 trinomial that we can factor. So you can either factor it in place like this, you can go off to the side, do a little side calculation for this thing, and then come back. So what I'm going to do is play a times c to get negative 10. And I need two numbers to multiply to get negative 10, add to get negative 3. So that's going to be negative 5 and 2. So we'll break up negative 3b into negative 5b plus 2b. And now we've got a 4-term trinomial that we can factor there. So out of the first two, I can factor out a b, get 2b minus 5, and that matches 2b minus 5. So that's just going to be plus 1 times 2b minus 5. And last step then. Factor out that 2b minus 5, get 3b times 2b minus 5 times b plus 1. So this one kind of looks like an a not equal to 1 trinomial, except we've got higher powers here. So we can use substitution here. Right, set it equal to the variable part of the middle term. So a is k squared. That turns this into 2 a squared minus 5a minus 3. And now we have a standard 8 and it's not equal 1 trinomial. All right, so AC, 2 times -3, that's -6. And -6 breaks into, say, -6 and 1. So we can rewrite this as 2a squared minus 6a plus a minus 3. All right, now the first two I can factor out 2a, get a minus 3 plus 1 times a minus 3. And that gives us a minus 3 times 2a plus 1. Now we'll just back substitute then, stick in the k squared back in there, and we get k squared minus 3 and 2k squared plus 1. All right, next up, 22. Another substitution problem here. Notice that this looks like a quadratic, except we've got these binomials in there. So if I just define a variable x to be the binomial, now I can rewrite it as 3x squared minus 11x minus 4. Now I've got a standard a not equal 1 trinomial. So AC method. 3 times -4 is -12. And -12 breaks up into -11 and 1. 12 and 1. I'll think about that at 11. Okay, so now we can break up at -11x into -12x plus x. Now we've got a 4-term trinomial we can factor. So I'm going to factor out a 3x here and get x minus 4 plus 1 times x minus 4. That gives us x minus 4 times 3x plus 1. And now we've got a little bit more work to do because we define x to be r plus 2. So we're going to back substitute. We're C and x, put an r plus 2. And if necessary, if you're next to a constant, put in parentheses. So here we got r minus 2. And here we have r plus 7. R minus 2 times 3r plus 7. Something is a mess. Why did I define x to be r plus 2? No idea. So I saw that 5 and thought it was 2. That was my mistake. Okay, so that's going to be a 5 here. And that's going to be a 5 here. So that makes this r plus 1 and 3r plus 15, 16. All right, next up, 26. Got 9t squared minus 49. All right, so we have a 2-term polynomial. So this is either going to be GCF or difference of squares. So do we have perfect squares? Yeah, we got 9t squared and 49 are all perfect squares. This is indeed perfect difference of squares. So a is going to be the square root of the first term. So that's 3t, and b Square root of 49 is 7. There's A and B, so stick in the formula, 3t plus 7 and 3t minus 7. And next up, 29. K squared minus 12k plus 4. Now this can just be done with the AC method. You can do it like that. But if you recognize that this is a perfect square trinomial, perfect square here, and this is 2ab. So that means we can take the square root of the first term and get 3k. And for b, square root of the second term and stick it in the formula, 3k minus 2 squared. But if you do it using the AC method, you get the same answer. Number 30. R to the third plus 27. All right, so we got a two-term. I think last time I said two-term, it was either GCF or difference of squares. Oh, there's one other. And then see, there's sum or difference of cubes. And here we've got sum of cubes. Perfect cube here, perfect cube here. So for A, we're going to take the third root of R to the first, and that's R. And for B, take the third root of 27 to get 3. And now we just need to plug these two things into the formula. So since it's addition, the first one is addition, R plus 3. We got R squared minus, change the sign in the middle term. A times B is 3R plus B squared. That's 9. So R plus 3 times R squared minus 3R plus 9. And next up, we've got 31. There's 31. 125x to the third minus 1. So you got some more perfect cubes here. 125 is a perfect cube, x to the third is a perfect cube, 1 is a perfect cube, so we have a difference of cubes. Take the third root of the first term and get 5x. And for b, we'll take the third root of 1 and get 1. All right, now we've got difference, so we're going to start with subtraction. 5x minus 1. And now we'll do a squared, which is 25 x squared. And switching signs from negative to positive. And we've got a times b, so that's just 5x plus 1 squared, which is 1. 5x minus 1 times 25x squared plus 5x plus 1. And next up, number 38. Right now, we're going to start solving equations with that. So here's where we use the zero factor property. Create two separate equations out of these. We got things multiplied together equals 0. We can break it up x plus 2 equals 0, and x plus 1 equals 0. Because if either one of these equals 0, then we're good. All right, so solve this one, subtract 2 from each side, and get x equals negative 2/5. And over here, we get x equals negative 1. All right, they're not all going to be set up like that, though. Let's look at number 44. This one will require some factoring. Now we can, right off the bat, factor out a GCF, because 4 divides evenly into 4 and 36. In fact, I'm going to factor out a negative 4. Now I'll turn this into x squared minus 9 equals 0. Now, the nice thing about having an equation equal to 0 is we can just divide by any constants out front, divide both sides by negative 4. Those go away, and we get x squared minus 9 equals 0. Now we have difference of squares, so we can factor this into x plus 3 times x minus 3. And then use the zero factor property to split it up into 2 separate equations. X plus 3 equals 0. X minus 3 equals 0, so we get x equals negative 3, and x equals 3. $46. So we're going to need to work with this one a bit. We're going to need to get everything off to the left side. So first thing we need to do before we can move this negative 3 over is FOIL here. So first, 2x squared outside, inside, left. Combine these two middle terms. And now we can finally move the 3 over by adding 3 to each side. And now I've got to set up to factor. All right, so we need AC method, 2 times 1 is 2. We need 2 numbers that multiply to get 2, add to get negative 3. So that's negative 2 and negative 1. Now here I can factor out 2x. Get x minus 1. Here I can factor out a negative 1 and get x minus 1. So that gives us x minus 1 times 2x minus 1 equals 0. All right, zero factor property, split it up. And so we get x equals 1 here and x equals 1/2 over here. So there's a sample of all the different problem types from this chapter that you might see on the final exam. Practice each type until you got them mastered. So you're going to see GCF, factor by grouping, A equals 1 trinomials, A does not equal 1 trinomials, difference of squares, sum of cubes, difference of cubes, and then ones that kind of mix up these different techniques. And that is it for today. See you next time.